For x between 0 and 1, the function f of x satisfies the relations, this one and this one. What is the value of this expression? Express your answer as a common fraction. So what we see here is what's called functional equations. For the function we don't know. And we would like to know the sum of values of the function at some specific points. So how can we approach this problem? Well, first what I'm going to do is I'm going to look at these numbers. Okay, 2/3, 2/5, 2/7. I have them, right? So what's going to happen if you start plugging them in this expressions instead of x? What's going to happen if I say x equals 2/3? What's going to happen with these formulas? In the first one, I'm going to get this. In the second one, I'm going to get this. Now, when I look at this one, I see something familiar, and that is 2/5. F of 2/5 is the next term, which can be expressed through the previous term. Interesting. The second one, basically we're expressing f of 2/3 through f of 1/3. I don't know what to do with that right now. But let's look here, because there's something promising here. So, okay, I'll say, okay, what if I take x equals to 2/5? What am I going to see here or see here? And what do I see? I see that I can express f of 2/7 as a third term through the previous term, like in the same way as we did with 2/3 and 2/5. So now the question is it the general trend? Is it the general way when we have the next term expressed through the previous term? Well, let's take one of those terms. In general term is 2 over 2k plus 1, where k is an integer, from 1 to infinity, basically. So if we plug that into this formula, we're going to get this. But notice what happens here. This is my x, and this would be the next term in this sequence. Because the terms go like, if you look at numerator, it's always 2. We have it here. Denominator goes through odd numbers. You know, the 3, 5, 7, 9, and so on. And what we have here is this is an odd number, and this is the expression for the next odd number. Okay? So yes, we could express the next term through the previous term, and the next term is the previous term times a constant, and that's the same constant for really anywhere, right? 1/2 here, 1/2 here, 1/2 here. And this immediately should kind of tell you, well, this looks like a definition of geometric sequence. It looks like what I have here are the terms of geometric sequence. And what I have here is an infinite sum of the terms of geometric sequence. Okay? Let's use that knowledge. So first of all, in geometric sequence, we can express the number, an element, not just through the previous element, but also through the first element. In this case, f to 2/3. And this is how it's going to look. And now our expression we're trying to find could be rewritten like this, through f of 2/3 times 1/2 to different powers. Now each term has this f of 2/3. We can pull it out. And we're going to have f of 2/3, and here we have actually a sum of powers of 1/2. Now let's rewrite this. And now let's take care of this guy. This is kind of thing we probably should know how to do it. One thing to know that this is a sum on infinite terms of geometric sequence. And we can use a formula for geometric sequence, or sum of the infinite terms of geometric sequence, which is actually this formula. So, and we can see that if I have 1 plus x squared and so on, like I have here, in my case x is 1/2, then all the sum should give me 1 over 1 minus x, right? The only restriction I have where I need to be careful is that x should be between -1 and 1, and well, in my case it's 1/2, so I satisfy this condition. So this guy here is 1 over 1 minus 1/2, that is, this thing is 2. So we can rewrite this parenthesis as simply a factor of 2. All right. So now what we got what we want to find as 2 times the value of a function at point 2/3. So, but now I actually need to find this f of 2/3. The one thing I can try to use is this expression that takes me from 2/3 to 1/3. Well, it doesn't completely solve the problem, but maybe that's something we should think about. Maybe we can put 1/3 and get something out of it. But before going there, let's look at this equation. This equation is interesting. It's related 1 minus x to x. And it has one specific point when x equal to 1/2. In this case, what you have here is the same as what you have here. Okay? So we got f of 1/2 as a function of f of 1/2. So we can solve this equation. It's easy to see that f of 1/2 has to be 1/2 actually. All right. So I am actually in a better probably position now. At least I know the value of this function at one point. Okay? But now let's go back to our 1/3. We got this 1/3. Maybe we can do something about it. We'll plug it into this equation. Well, in this case I get f of 1/3. Well, doesn't help me much, because I do know f of 1/2, but this expression takes me away from this, from 1/2, okay? Takes me to 1/4 from 1/3. But then, wait a second. We had 1/3, we had 3 here, we got 4 here. We want, seems to be from the smaller denominator to a larger. Okay, but what's going to happen if I put 1/2 here? Would I get 1/3 here? What do you think? Let's try. So we take x as 1/2, and yes, voila. I can express 1/3 through 1/2. And I know what 1/2 is. F of 1/2 is half, so the answer is 1/4. Now I know f of 1/3, so I can calculate f of 2/3, right? And now, well, I guess I know what this sum is, because I have the value for 2/3. Okay? And that's what is 3/2, or 1 1/2.